So now the next topic after the evolution of the earth, we will discuss about the internal structure of the earth. Means after the earth has evolved, it has formed into different layers. It has formed into different layers. As I told you, when it was in a molten state, that was the liquid stage, many rocks were falling. Bombardment was there. Many rocks were falling. Right? So we call it as a bombardment. So what happened? That went and settled at the bottom. But are the rocks are still present? No. They have become into a molten material. Right? But there is a different layers are present. Right? Where we are standing, we are called as a crust. Then what is the depth of the crust? Can we go to a depth inside the earth? No, we cannot go. Scientists are digging, right? But they cannot go more than 6 kilometers of depth. Why? Because the radius of the earth is around 6,000 kilometers. The radius of the earth is around 6,000 kilometers. And it is very impossible for either you or me or the scientists to reach the depth. Right? So the crust is quite near about 100 kilometers of deep. Then after that we have molten stage. So, and why it is not possible for the people to dig more deeper? The reason is that gases. There are very poisonous gases are present in the internal part of the earth. And because of the poisonous gases, people are unable to go beyond 6 kilometers. For example, let us talk about mining, right? Many particular places we see minings are been done and natural resources are been like minerals, metallic or non-metallic minerals are been removed. But are they going very deep into the earth or you can say structure? No, they are unable. Why? It is only due to the poisonous gases which are present, right, in the earth crust. Okay, so more. Let us learn in a detailed way about this particular internal structure of the earth. Alright. So, this internal structure of the earth is divided into three particular layers. Three layers are there. The first layer is the crust, the second layer is mantle, and the third layer is core. You can just check it in your textbook also. Right? You can check it in the textbook. You can see here, this is your structure of the internal structure of the earth. Right? The first one, where we stand, that is first one is the crust, the second, the red one is the mantle, and the third one is the core. And this core is divided again into the outer core and inner core. Okay, so you can just check it out this particular figure here, and I will explain you the in a detail. So the first one is the crust. So crust is the uppermost layer of the earth, uppermost layer, where we are standing, where mountains are present, plateaus are present, where rivers are flowing, right, where agriculture is taking place, everything occurs or life occurs on the crust, not but in the mantle. Mantle life does not occur, my dear children. Only on the crust only the life occurs. So the crust is the first layer of the earth, and it is up to a depth of 100 kilometers. It is up to a depth of 100 kilometers. Now where we are standing, this is the upper layer of the crust. This is the crust. And this crust is up to a depth of how much? 100 kilometers. Up to 100 kilometers is the crust. Then what is present in the crust? What is present? What are minerals are present? It says there are various kinds of rocks are present in this crust. From the rocks only we will get it minerals, right? There are so many rocks, are there, different rocks are there. Iron ore we get from the rocks, right? So like that there are so many rocks are there from where we get different type of metallic and non-metallic minerals. Okay, so crust is to a depth of 100 kilometers, and what is present inside the crust? Various kinds of rocks are present in the crust. The next particular layer is mantle, right? Mantle, the second layer. So this particular mantle is to a depth of, so it is extended from where? It is extended from 100 kilometers to 2,900 kilometers. It is extended from 100 kilometers to 2,900 kilometers it is extended, right? Then what it more says that the important thing of is that this crust what is present, the first layer of this earth is floating on this mantle. For example, you take what do you call as a wooden block which is quite heavy only, right? If you put it on the water, what happens? The wooden block will float. It does not submerge, but it will float. Same way, our crust is floating on the mantle. Our crust is floating on the mantle. Then what is present in the mantle? What type of minerals are present in the mantle? Chemicals called silicates. Chemicals called silicates are present in the mantle. What chemicals are present in the mantle? Silicates. Silicates are present in the mantle. Okay, so that is the specialty of the second layer. Third one is the core. So core is extended to a depth of 2,900 kilometers to 6,376 kilometers. Wow. Okay, so this core, which is the third layer of the earth, is extended from 2,900 kilometers to a depth of 6,376 kilometers. And this particular core is composed of dense and heavy substances. Dense and heavy substances like iron and nickel are present. So what is present? What type of minerals are present here? Iron and nickel are present in this layer. And talk about this core is divided into two layers. You can see here it is divided into two layers. There are two layers are there, right? And what is present in the two layers, right? So the outer layer and the inner layer. This is the outer layer and this is the inner layer. So outer layer or called as the outer core. So outer core is from 2,900 kilometers to 5,100 kilometers, right? This is the outer core, 2,900 to 5,100 kilometers, right? That is the outer core, right? And what is this? Minerals are present in this, right? It is composed of liquid metallic like nickel and iron. Means this nickel and iron are present in liquid form. So clearly says liquid metallic like nickel and iron are present in the outer core. The last one is the inner core. Inner core is extended from 5,100 kilometers to 6,376 kilometers, right? And this is composed of iron compounds and heavy substances like gold, right? This inner core consists of heavy particular, right, substances like gold and iron compounds. So this is the structure of the earth, internal structure. We are just standing on the earth's surface. We can see only soil is present. Somewhere you can find red soil, somewhere you find black soil, somewhere you find loamy. Different type of soils are present where you find different landforms also. But what is present in the internal structure we did not know. But through this particular research done by the scientists, we have come to know that yes, there is internal structure also is present inside the earth, which has a variety of mineral resources. Now, when talk about this particular internal structure of the earth, right, does this structure changes? Yes, it changes. Have you seen volcanoes? Have you observed about earthquakes or tsunamis? Yes, this all occurs due to the movement of the structure of the earth, isn't it? So how does it move? Is there any kind of things are? Yes, we can see that this crust is floating on the mantle. It's floating on the mantle. Right? Because of the high pressure of the mantle, what happened? The crust moves. The crust moves, and what happened? Because of the movement of the crust, sometimes what happened? Earthquakes will take place, tsunamis will take place, or sometime we can see the molten material is coming out of the earth crust and forms volcanoes and form the volcanoes. So with this we can understand that earth is still active. Earth is still active. Earthquakes are taking place. Why earthquakes are taking place? Because of the movement of the mantle. Volcanoes are occurring. Why it is occurring? It is because of the movement of the mantle. Right? Tsunamis occur. Why tsunamis occur? It is also a movement of the mantle. Right? So, because of these movements of the internal surfaces, right, we can understand that yes, earth is still active. Earth is still active. We do not know whether earth is moving or not. We cannot see with our bare eyes. But with this, what you can say, volcanoes, or because of the earthquakes or tsunamis, we can understand that yes, still earth is in active. So we can see here the last paragraph of the topic where it says clearly, right, this constant process of formation and destruction of the crust explains the fact that our earth is still very active. What to say? Constant process of formation, right, where we can see sometimes the crust will go inside and sometimes the molten will come outside. Crust, it goes inside. For example, this is the earth. Suddenly there will be earthquake. And what happened? This material, what is present, it goes, it becomes here. It becomes like a cave. The material goes inside. Right? And what happened? It becomes molten. And where in some places, right, in some places, the molten is pushed upwards. The molten is pushed upwards. We say volcanoes. Volcanoes. And what happened? The materials float and volcanoes are formed here. Volcanoes are formed. Isn't it? So, with this we can understand that yes, earth is still very active. The crust on which we live is still being changed by earthquakes, volcanoes, subduction of land and rise of mountains due to processes happening deep down into the earth. Because of the process happening deep down the earth, this particular different process are take place. Volcanoes are occurring, earthquakes are taking place, sometimes tsunamis also occur, sometimes different mountains are also formed on the earth crust. Question is given over here. Do you know? You can see the question over there, page number 5. What do you say? Do you know? The crust forms only 1%. The crust forms only 1% of earth. It is only 1% of the earth, and where 16% mantle and the rest is 83% is core. Okay, so this clearly says, if we assume that the size of the earth is equal to the size of the egg, the thickness of the crust is just about the thickness of the shell of an egg. Have you seen an egg? Have you seen an egg? Egg, white color. On the top is white color, but inside what is there? There is something is there. Yellow color and white color also is there, right? So, if you see that the top layer of the egg, the shell what we call, it is the crust. So, crust is how much percent? Only 1%. And the remaining, the layer what is present inside is mantle 16% and the core what is called as 83%, which is divided into inner crust and outer crust. Hope you have understood about the internal structure of the earth. Is the earth still active? Yes, the earth is still active. Volcanoes, earthquakes, tsunamis. So with this we can say that yes, Earth is still active. So we have discussed about the internal structure of the Earth. Now let us learn about the movements of the Earth crust. Right. So how these movement took place? As I told you that there are three layers are there: crust, mantle and core. So this crust is present on the mantle. So what is crust? A hard layer where we are standing, right? We are standing on the hard layer, that is a soil, what we call as. So this particular hard layer, what we call as a crust, was actually a larger part. Today we say 7 continents are there, but actually it was only one particular super massive continent called as Pangaea, right? But who gave this name? Who gave this name? A scientist, a particular meteorologist, a geophysicist named as Alfred Wegener. He written a particular theory called as continental drift theory. So through that theory, he has proposed that this particular landmass, which today has been divided, was actually a larger landmass, around 200 million years ago. 200 million years ago, it was a larger landmass which was called as a massive supercontinent known as Pangaea. Later slowly started to move, right, and started to break, right, started to move and break and form the present continents. So what does he tells us in this particular continental drift theory? He says that this continental drift theory explains about our present arrangement of the oceans and continent. So the present oceans and continents, right, are being clearly explained in this continental drift theory. He says how these continents have moved and how these oceans have been formed. He has mentioned in this continental drift theory, and where he says that this particular Earth, right, consisted a large landmass, right? You can see this was the Earth and there was a large landmass. Right? You can see in this book also here. There's a large landmass is present here, the brown color one. So this particular large landmass, or called as a supermassive continent called as Pangaea, and that was surrounded by a larger water body. It was surrounded by larger water body called as Panthalassa. So this massive continent called as Pangaea, right? And whereas the water body is called as Panthalassa, right? So this is land and this is water. So Panthalassa is a larger water body which was surrounding the Pangaea, that is a land. So this has been explained clearly by our geophysicist or meteorologist Alfred Wegener. So you can see here how it slowly started to move here, right? So first around 220 to 20 million years ago, it was only one particular super massive continent. Then slowly, right, it started to divide. Now what was dividing it here? We can see a red particular line is going, and that is called as Tethys Sea. So this Tethys Sea started to divide this particular landmass into two divisions. One is Laurasia, another was Gondwana. So when this particular Laurasia and Gondwana was divided around Mesozoic era means around 220 millions at the time, or 65 billions. Okay, so 200 million years ago, this particular Tethys Sea started to divide this particular large massive continent called as Pangaea into two divisions. The upper division was called as Laurasia and the southern division was called as the Gondwana. Then slowly this particular large land mass also started to move different sides, and sometimes they collided with each other. Collided means what? They used to come together and they used to collide with each other, and they used to break also, and they form a smaller continent. That is, the present continents were formed. So this clearly is been explained in this continental drift theory, that how this large land mass, right, broke down into a smaller continent to form the present small continents at a different places. So clearly here says this massive supercontinent existed 220 million years ago and slowly started breaking into large sections and moved away and formed continent, the present continents, right? And this Pangaea, which broke up to form, when this Pangaea broke up in the Mesozoic era, it started to break up. That is 200 million years ago. It started to break up. And what made it break? The Tethys Sea. A Tethys Sea was there, which made it to break into two halves. That is Laurasia and Gondwana. And at present, what are the particular continents were there in the Laurasia? North America, Greenland, Eurasia, north of Indian subcontinent. North of Indian subcontinent was present in the Laurasia. Then what did the Gondwana consisted? What did the Gondwana consisted? Gondwana consisted South America, right? Then America, Madagascar, India, Arabia, Malaysia, then East Indies, Australia and Antarctica. The present, these are the present continents which were present in the Gondwana region. So what made this a large structure to break into the Tethys Sea? The Tethys Sea, right, broke this, right, into two, right? So there was a water body, right, called as Tethys Sea, which divided Pangaea into two particular land masses. So this is how the continental drift theory explains about. There are certain questions also are given over here. Look carefully at the map of the world. Do you find some continent looking as if they are two pieces of a jigsaw puzzle? Name those continents. Now if you look at the continent, there are so many continents are there. For example, like North America is there, South America is there, right? Africa, Europe, or you can say Asia is there, right? Australia. Do you think that they are two pieces of jigsaw puzzle? Yeah, there are some continents are there which can be called as a jigsaw puzzle. For example, Europe you can take, Africa you can take. Like that, there are some continents are there which can be called as a jigsaw puzzle. Okay. In which direction is Australia moved? Right? You can come across from here. If you take this particular pictures, we can see here to which particular direction the Australia has moved. Australia has moved to the east direction. It has moved to the east direction, right? Then I have a question. In which direction is India moved? In which direction India moved? India moved to northeast direction. India moved to northeast direction. Okay, India moved to northeast direction. When this Gondwana and Laurasia collided with each other, at that time, India moved towards the northeast direction. So, as we have understood that this particular landmass, which was a huge, massive supercontinent called as Pangaea, was slowly started to drift away. Means slowly started to move away from each other in a different direction, right? So, it was broken into two blocks. It was broken into two blocks, that is the northern part and the southern part, by a deep shallow sea called as Tethys Sea. So, after these two particular pieces have been broken, right, they slowly started moving in different direction also. Some northeast, some northwest, some to the southeast and to the southwest. For example, you take Australia, right, which was part of the massive supercontinent, it started moving toward the eastern direction, and where North America and South America, they started moving towards the west direction. So we can understand that this massive continent broke down into large pieces of land masses and started moving into different direction. So do you think that these masses, land masses, are still moving? Yes. These continents, what you call as North America, South America, Europe, Asia, Africa, this continent, still they are moving very slowly. We will not feel it. We will not feel it, but they are moving. Why they are moving, how they are moving, we'll try to discuss that in the second lesson. Second lesson, that is lithosphere. Why these particular masses are moving, how they are moving, we'll discuss in an elaborate way. So next we are going to discuss about a particular topic, right, where we'll not be discussing about the internal structure of the earth or evolution. We have discussed already, but how to find out the different places on the earth, how to find out the land masses. With what we have to find out the land masses, that we'll try to discuss in the next particular topic, that is the Earth's grid system. The Earth grid system we'll try to discuss about. The Earth grid system. So now what is Earth grid system? For example, you want to find out a place on a globe or a map. You just open the book and you just place your finger on the world map and you start finding out whether it's a world map, whether it's an India map, you start finding out. But to locate it very easily, we can use latitude and longitudes. So to find out places on the globe, we can use latitudes and longitudes. For example, if you want to find out your own city, Hyderabad, you want to find out your own city, Hyderabad. Let us take Hyderabad. So Hyderabad is what? A place. It's a place. It's a place. It's a place. Okay. Where is Hyderabad? In which country it is located? Right? It is located in India. It is in India. Where is Hyderabad? It is in India. So what is latitude and longitude? Right? So how we can find out? So everyone, I think you may be having a atlas book. So with this atlas book, it is very easy to find out your latitudes and longitudes. Very easy to find out this particular place. How? This particular atlas book. See, I'm having this is the oldest edition. So you may be having a new editions. You may be having a school atlas books. So in this, at the last, right, there are pages are there where we can find, we can say general index is given there. So in this general index, what they have given? They have given the name, right, place name, country name, and they have given latitudes and longitudes. So with this, we can find out the place very easily on a globe. We can find out very easily on a globe. So for example, Hyderabad. So Hyderabad, in which particular page it is? In the page number 59. Right? And where? What is the latitude? Latitude is 17 degrees. 17 degrees, 38 minutes east. North. Latitude. And what about the longitude? Longitude. It is around 70 degrees east longitude. 70 degrees and 38 minutes east longitude. So with this latitude and longitude, we can easily find out where is Hyderabad located in the world. Very easily find out. So latitude and longitudes, this together forms what we call as a grid. It is formed as a grid. So what is a grid? I will write the definition on the board, right? So what is a grid? A network of latitudes and longitudes drawn on the globe is called a grid. What is a grid? A network of latitudes and longitudes drawn on the globe is called a grid. Still not able to understand? I will draw the globe, right? This is the globe. Okay, there is a globe, right? Assumption only, right? So this is a globe. Okay, so I am drawing the latitudes. I am drawing the latitudes over here. These are the latitudes, horizontal line. We call as a horizontal line. So these are latitudes. Then what about longitudes? Longitude are semicircle line. They are semicircle. These are circles. They are semicircle lines drawn vertically. Vertically. They are drawn like this. Okay. Now, if you look at what I said, a network of latitudes and longitudes drawn on the globe. A network of latitudes has been drawn and longitude. Now, what do you find over here? A rectangular shaped box is found, and this is called a grid. So, latitude, for example, what is the latitude given for Hyderabad? 17 degrees and 38 minutes north. So, this is equator. Assume this is equator, 0 degrees, right? So, this is north and this is south. So, 17 degrees and 38 minutes east, north. So, north means what? Northern hemisphere. It is located in the northern hemisphere. So, for example, let us assume this. So, this is latitude, 17 degrees. 17 degrees, not latitudes, right? And what about this? What about this? 17 degrees, 70 degrees. 70 degrees, 38 minutes east longitude. So, this is the latitude and this is the longitude what I have drawn. So, with this, we can find out the place very easily. We can find out few more places on the earth also. For example, there are so many places where volcanic eruptions take place, earthquakes take place. Find out the places where earthquake, volcanoes takes place with the help of the latitudes and longitudes. First, find out the place. For example, I'll give an example. Japan is a place where volcanic eruptions and earthquakes are very frequent. So, Japan is located in each particular latitude and longitude. Similarly, there may be different countries. You can take Indonesia, you can take Thailand, you can take Philippines. These are some other countries I have given examples where frequent earthquakes take place. Not only there, in North America and South America also, frequently earthquake and volcanoes erupt. So, find out that particular places with the help of latitudes and longitudes, where you will find in the atlas book, and that too at the end of your atlas book, where they have given in an alphabetical order. They are given in the alphabetical order. Now, is there any use of this grid? Yes, there is a use of the grid. So, in what way this grid is useful? Grid is used to locate a place on the globe. First point, a grid is used to locate You will be confused here. The grid is used to locate a place on the globe. That's the first use of the grid. Second use of the grid is to know the climatic conditions, whether it's hot or cold. So this grid will help us to know whether that particular place is hot or cold place. And third point, it's a very important point, that is, it helps to know the time, right? It helps us to know the time of a place. With the help of the longitudes, we can know the time. Sitting here in Hyderabad, we can easily know what is the time in Chicago. Sitting here in Hyderabad, we can know the time of Sydney. Sitting here in Hyderabad, we can know what is the time in Pakistan or Bhutan or whatever the countries you want to know. We can know with the help of the longitudes. So these are a few particular uses of the grid. What is the grid? Again, we'll recollect it. What is the grid? A network of latitudes and longitudes drawn on the globe is called a grid. Network of latitudes, horizontal lines, right? Longitudes, vertical lines. So they form a rectangular shape, right? And that is called as a grid. What are the uses of a grid? It will help us to locate a place on a globe. Second, to know the climate of a particular place, whether it is a hot place or cold place. For you want to go to somewhere. So with the help of the grid system, we can easily find out whether it is a cold place or a hot place. And lastly, to know the time of a place. So this is about the Earth grid system, right? Next, we will go right about the different particular places, right? Or we can say, you might have learned about this in the earlier class also in the 8th class. That is, which particular continent is located in which particular part of the globe, right? So we call as hemisphere. In which particular hemispheres they are located. So here the table also is given here. We'll try to do this. For example, so now let's look at this table over here, given here in your textbook. Now this black shaded one, I have drawn over here. The black shaded one are the hemispheres. Hemisphere. Now what is hemisphere? Hemisphere means what? The half of the earth. Hemi means what? Half. Sphere means circle. Half circle. Understood? So here, this is a half circle here. Understood? Hemisphere we say. So we have half of the hemisphere here, half of the hemisphere on the western side, half of the hemisphere on the eastern side, half the hemisphere on the southern side here. So now what continents are there in the northern hemisphere? What continents are there here? So there are North America, right? Asia, Europe, right? So these particular continents are there in the northern hemisphere. Then what about the western hemisphere? What continents are there in the western hemisphere? North America, South America, only a small part of Antarctica is present there in the western hemisphere. Then what about the southern hemisphere? What continents are there in the southern hemisphere? Australia, Antarctica, South America and Africa. These are the continents which are there in the southern hemisphere. Then what about the eastern hemisphere? In the eastern hemisphere, in the eastern hemisphere, we see Africa is there, Europe is there, Asia, Australia and Antarctica. These all the continents are there in the eastern hemisphere. So as I told you, what is hemisphere? Hemi means half. Sphere means circle. So half of the sphere we call as hemisphere. So now I think we have understood about the clearly what is hemisphere and what continents are located in the western hemisphere, what continents are located in the eastern hemisphere, what continents are located in the northern hemisphere, and what continents are located in the southern hemisphere. Now next we'll learn about the latitudes and longitudes. So what are latitudes, what are longitudes, we'll try to discuss in the next topic, and what are the uses of it, how many latitudes are there, how many longitudes are there.